Hello, everybody, and welcome back to another live stream here at Cerbos. I am Dan, your host, as always, and I am pleased as punch to be here with you today. We've had a number of great live streams over the past month. I'm really, really happy to be sharing this time and the space with the community and with a bunch of great guests that we've had on over the past month. Today I have another great guest, one of my coworkers, actually. His name is Alex, and we're going to be doing an AMA and Ask Me Anything today. So Alex, why don't you go ahead and introduce yourself?
Yeah, thanks, Dan. Hey, everyone. Alex Olivier here. I am one of the co-founders and chief product officer at Cerbos, and I am happily to admit I'm an engineer at heart that is now in the world of product, but working on a problem, and we are generally at Cerbos working on a problem that I've had to solve numerous times at various different businesses, various different companies, and trying to solve it once and for all, which is this absolute headache that authorization can be if you don't think about things in a scalable approach, let's say.
Right. Well, we're definitely going to get into that, thinking about scalable approaches, thinking about the headaches of authorization and so on and so forth. As I mentioned at the outset of the live stream, this is an AMA. It's an Ask Me Anything. And we have been gathering questions, as we always gather questions from the community. We've been gathering questions over the past week, but of course, we've been gathering questions for weeks, for months, for years from the community, from you, from our customers, from our open source contributors at conferences, wherever we go. We get a lot of the same questions. When
Mm.
we get them from a year ago, we get them from a day ago. And so we've organized them into a couple of different themes. And we're just going to kind of take a look at those themes and see if we can come to some, if not conclusions, at least generate some good additional questions to ask to guide us in the future, to help us understand what we're doing, right? As an industry, as developers, as practitioners. And so without further ado, I'd actually just like to dive in to our first sort of thematic round sort of set of questions. And this is one near and dear to my heart. I actually did a whole presentation at this at DevOps Days recently, and it's around stateless. So like, what is stateless? What is state in the first place, and how can you not have it? Right? Like, what does that even mean? Does it relate it to serverless? How does it work with microservices, et cetera, et cetera? So to narrow that down into sort of a specific question, we have a specific question, which is, can you just compare stateful versus stateless? What do these two words mean, and how are they different, Alex?
Yeah, absolutely. So let's first go into those terms, then we'll apply it to kind of authorization. So every application has state. State is the information, the data, the records that users are interacting with inside of your system. So if you're building a social network, your state is the tweets, it's the users, it's the direct messages. Your state in a more enterprise context, it's like the records in your ERP, it's the employees in your HRIS system, etc. And that is just the data, the source of truth. The system of record is a term that you'll hear sort of here as well. And ultimately, in traditional systems, we won't go into the AI world just yet. That's just stored in your database. And so your data set is kind of what the application runs on top of. And that is state that is then used and computed and mutated upon inside an application during the course of using it, either by humans or by some sort of programmatic process. Now, in the context of authorization, state is all about the information required to make a decision. So I want to figure out whether Dan can access a particular record inside of a system and be able to edit it, let's say. So the state that the authorization now needs to know is who is Dan, what roles and groups and teams is he in, and also what is the resource he's trying to access. So what is that record? Which tenants it belong to? Who's the owner? What is the status of it, etc. And that is information and data points about both the principal or the human or the user making the request and the actual resource. So in the context of authorization and stateless and stateful systems is where is that data stored? Where is the source of truth? And in the two models, of which there are kind of opposite ends of the spectrum, you have the stateless approach, where the authorization layer doesn't know anything about this. And you have the stateful approach, which is where the authorization system holds that data. And there's pros and cons of both approaches here. So if you look firstly at the stateful model, this is the case where you have your master data set, your system of record that is being used interacted with by users to use the application. And then to do the actual authorization, to do the permission checks, to do the access controls, those kind of things, you essentially have to copy that data over into your authorization layer. And the nice thing with this approach is firstly, it allows you to simplify what data you're stored. You don't need to copy the entire ERP record, you can just copy the attributes that are relevant to the application, and that gives a simplified data set for the authorization to sit upon. So your authorization layer might connect to your authentication provider, your IDP, your directory, and suck in your users, their roles, their groups, and it would connect to your database, your third-party API, etc., and suck in the database and attributes about your resources. Then when it comes to making a decision, all your application needs to do is say to that system, hey, here's this user ID trying to do this action on this resource ID. So the actual service that calls to the policy decision point, as it's called in the authorization space, only needs to provide minimal information because all the attributes and the data behind that is already stored inside the authorization system. That's how it works in stateful model. In the stateless model, your authorization layer doesn't know anything. All the data that it needs and all the inputs it needs about who a user is and what the resource is needs to be provided at request time by the application doing the permission check. And that way, the policy decision point is purely evaluating based upon the data that is coming in on the actual request. And then if we compare and contrast what this means in terms of how these systems are built, in a stateful model, it now means when you deploy an authorization system, you also need to go and build these synchronization systems, which will do change data capture or subscribe to database topics or Kafka topics, whatever, and build up its state store. It will ingest skim events from an IDP, etc. And then you're maintaining basically a shadow copy or a clone of your underlying data. And then you need to also scale out and distribute that data set store so your authorization systems can do it. Now, the advantage is it simplifies the application integration. But the disadvantage is you now need to maintain and keep this cache up to date. And all the things around, all the concerns you would have traditionally heard around eventual consistency and distributed data problems and how to do cache invalidation, all that stuff, you then have to deal with these problems when it comes to authorization. But the advantage is it makes the actual application checks much simpler. Now, in the stateless approach, which is what Cerbos is, Cerbos itself doesn't need to hit a database. It doesn't need to query anything. When a request comes in, here's this user with these attributes trying to do this action on this resource with these attributes. Cerbos can then evaluate that against the policies completely in memory. It doesn't have to go and hit a database, doesn't have to go and hit any external data stores, doesn't need an underlying data set or anything like that. It can make a decision based on what data you give it. And then what that means from like a architectural standpoint is because your policy decision point, your authorization system, doesn't require an underlying data set, you can actually horizontally scale it. So you can spin up a policy decision point, a Cerbos instance for the lifespan of a single request. You can do it as sidecars. You can have it dynamically scale up and down along with your application and without any other concerns about keeping the underlying data set up to date. Because the authorization system, the stateless authorization system, doesn't maintain a copy, doesn't need to be in sync or anything like that. You don't have the cold start problem. You don't have the state hydration problem, any of those sort of things. But you're then pushing the onus on the application to provide all the state at request time, which means it's always going to be up to date. And it's always going to be the latest and greatest information because it's coming directly from the underlying data store. But it does then put kind of an extra work on the authorization check calling system to be able to aggregate the state from those different sources. So it's really a trade-off based on your architecture. It really, the way we look at the world and Cerbos looks at the world is if performance is key, authorization is in the blocking path of every single request. You should be able to do an evaluation of an authorization policy and authorization check as fast as possible. So the moment you have to call out to some data set or an external API or God forbid over the internet, you're adding multiple milliseconds of latency, which is not acceptable when you're doing this in every single blocking path of every single request. And you then end up with kind of much more performant system, which is why with Cerbos, at least we kind of really are behind the stateless approach and does give you that scale. And we see that across our users processing a lot of volume, significant volume through Cerbos as an authorization layer without having to manage the kind of state management piece.
For sure. So that I mean that was a pretty wide-ranging answer. It was a much longer answer, I think, than I was expecting.
It's a complicated topic.
It is a complicated topic, exactly. And so, we use sort of Cerbos to illustrate the example because it's something that we're familiar with,
Yeah.
right? But it's not just for Cerbos, right? It's not something that we invented, right? The whole idea behind, stateless as a term, as a function, as a paradigm is really just this idea that any one request is going to be independent from any other request. That the requests are, if not idempotent, you're at least going to have, given the same set of conditions, you're going to get the same result back, right?
Yep.
That this the idea of being able to scale, this idea of having to deal with what is fundamentally state. The state still exists in the same way that serverless is still servers, but that the concept of state and how it's handled is handled in a different way. It's got to be handled at a caching layer, at an edge, on the client,
Yeah.
right? So on and so forth. So, when we talk about sort of stateful versus stateless, it's not actually a question of is there state or not, right? It's a question of where and how is that state being handled? Because of
Yes.
course, naming things is hard.
Always is.
Yeah, for sure. And that actually brings us right, to the next crop of questions that we have, right? We talk about the sort of the thematics, which is around scalability. So one of these questions that's going to naturally sort of crop up after we go, okay, well, stateless sounds great because I like horizontal scaling and I like, the modularity of the deployment model and so on and so
Mhm.
forth. But like, how do you scale that? How, and then maybe a broader question, this is sort of a second element to this thematic, right? Is how do you think about scaling, right? When is the right time to scale? How do you know to scale? What do you scale? What's the sort of the thought process behind what needs to get bigger or smaller for what reason?
That is a multifaceted question. And my naive answer to it is if you're thinking about scale, then there's probably some more work to do because I like systems that auto scale. Um, we're thankfully now in a world where compute is very elastic. We have these great sort of orchestration systems. Kubernetes has been the most obvious one that are kind of built to scale out and have things like horizontal scalers, etc. This is not something you should worry about if you're just starting out. This is not something you should worry about if you're doing an MVP. This is not the kind of thing you should worry about if you're doing a prototype. Hell, this is probably not something you should worry about until you've actually got, significant numbers of usage where you exceed the compute capacity of a single node. Um, the line I always kind of put in the sand where you should really take things a bit seriously is when people are actually paying you money for some service. That's when you need to make sure, okay, this thing kind of needs to scale because if I need high availability, I need to make sure that this service is up because we've got people, parting with their hard-earned cash for a particular service. And you want to make sure this thing's available and you make sure this thing also can survive peaks in traffic and spikes in traffic and those sort of things.
We actually had a guest last week, Jason
Mhm.
from Datadog, and the question of scaling, kind of came up there. The question of when do you know what to scale? When do you know where to put your engineering resources into these questions? And his answer, standard issue Datadog answer is when it begins to hurt,
Yes.
right? So if you have a service and that service is toppling over, that's a pretty good time to figure out how to scale that service.
Yeah, and I would maybe wouldn't go as far as toppling over completely. This is very much making sure that you've got things like SLIs and SLOs defined, making sure that you've got the observability in place, doing that small bit of work, hopefully small bit of work up front to instrument your application and to plug it into something like Datadog or one of the sort of open telemetry stacks that's out there and being able to see, okay, things are good, don't need to worry about it. And then making sure, I always like to think of it about the end user experience, find what that pain threshold is, not whether the CPU on the poor machine under your desk that's running your system is stressing, but more about when does the end user experience start to feel sluggish, and a lot of the time it does come down to does this feel fast? Does this feel like something that's nice to use? Because the moment things feel sluggish and clunky, yeah, that's usually a sign where it's now getting painful. And probably should go and figure out those things and figure out what does that actually mean to scale. And you can get very far with a simple database and a simple application on a single machine these days. Very far, and there's a lot of optimizations going on out there across the whole stack. But
There
I
are
was,
some startlingly performant
oh yeah,
websites out there that are running on a combination of, a simple local SQL,
Mhm.
some static web pages, a little bit of JavaScript, or
Yeah,
not even, right? Just rendered all on the server side and away you go.
yeah, exactly. So you know, pushing it far, but then feel the pain in terms of user experience or user expectations rather than underlying compute metrics or memory usage and those sort of things. They're obviously correlated, but that's when I'd seriously start considering things.
For sure. So you talk about scalability. The the two ways of talking about scalability, generally speaking, we talk about vertical scalability
Mm.
and horizontal scalability. And I actually had this question literally at DevOps Days London. I was there, it was back in September, and uh, there was a little bit of confusion
Hmm.
around these terms. Uh, they sound like they're the opposite of each other, but like everything, naming things is hard, and there's some overlap. So why don't we just clarify that? When we talk about vertical and we talk about horizontal, what are we talking about?
Yeah, so I think where this comes from is literally as you're building your like architecture diagram, the direction that you kind of move components in. So vertical scaling is to basically say, I have some compute node that's running some process, and I basically have two ways that I can get more compute. I can either make the one box that is running on bigger, so it can handle more, or I can which is vertical scaling, or I can horizontally scale, which means just create more boxes of a similar size and create multiple replicas of it. Um, and I think the consensus around what you should do has swayed a bit in the last 6 months or so. You know, we've gone through the journey of monoliths and microservices, and it feels like we're coming back a bit to modular monoliths, which seems to be the new term, or moduliths. Saw someone use the other day. Um, the underlying compute, the CPUs, the silicon that is being produced these days is so powerful, and you can get a lot out of a single chip. So actually, vertical scaling, or to turn that around a bit, having that single node, having that single um, compute machine, or just a few large machines, and scaling that way, vertically scaling by having more capacity, will get you very far and removes all the complexity of now having to worry about orchestrating workloads and how you do load balancing and all that, those sort of things. Um, Whilst if you go back maybe a year ago, the perceived wisdom and trend is you have microservices that you horizontally scale across a load of boxes, and that gives you your high availability and your performance. Definitely in the last 6 to 12 months, that has shifted slightly, but the kind of perceived wisdom today is still very much horizontally scale is how you kind of reach it. Using something like Kubernetes, which can and on top of a cloud provider infrastructure that can spin up nodes and spin down nodes and do horizontal pod auto scaling. That's I think where people may have heard of that horizontal piece the most. Um, Basically saying once this process exceeds X% of CPU and memory, just go and create another one next to it and then load balance the traffic. And that's the horizontal piece. Um, it definitely is getting a bit murkier right now around what should be considered best practice, particularly at least in my Twitter or X sphere. There's definitely a bit of pushback from paying the cloud provider tax, as it were, and just getting a bare metal machine that can handle a lot and run everything on that and vertically scale that way. Um, but we'll see. We'll see. That I think it's quite early for that. I'm leaving the cloud type motion. That seems
The
to be a
reality
thing.
is everything is cyclical, right?
Exactly.
Everything is cyclical. So, we went from the era of having room-sized machines that you would feed punch cards into, and then we went through, miniaturization, and then miniaturization, and we got networking, and all of a sudden we could have dumb terminals and we could have fat terminals, and we started to go, oh, well, the processing's done over here, but the rendering layer is done over here, and then
Mhm.
actually as the render side became more powerful because of the magic of miniaturization, we were like,
Yes.
oh, we're going to move some compute over to that side as well. And then, that was a form of scaling in a different direction. And we see these cycles, and the cycles are getting tighter and tighter and tighter. Whereas it used to take 5 to 10 years to sort of complete one of these technology loops. Now we're seeing these loops happen, in the space of 18 months, in the space of 12 months. It's true that, there's now, if you're on the sort of the bleeding edge is monoliths.
Yeah.
Let's do monoliths, and let's scale vertically. Let's put our monoliths on big fat computers,
Yeah.
which is great because that's what we were doing 5 years ago. So if you never migrated to microservices in the first place, you're good.
Yeah. I mean, the kind of the other interesting sort of vertice into this kind of problem space as well is around kind of edge compute and edge infrastructure, which is for some things you want to make sure that latency is as low as possible and that round trip as fast as possible. So you actually want to now push the compute as close to the user as possible. I'm like, well, is that horizontal scaling? Is that vertical scaling? If you're doing vertical scaling, does that mean you just need a big node at the edge? But then that's not really a thing yet. So there's this other kind of aspect to it. And going back to the kind of original question is like, when should you worry about scaling? These are problems that are much down the line. keep your code base, keep your deployment as simple as possible. Just stick it on a big beefy node, and scale up that way as you need it. When you start really feeling that pain of like, okay, this is a critical part of the stat of the monolith, which is getting the most traffic and is getting backed up or slow, etc. Then you start doing the modular monolith approach, where you start breaking that out and horizontaling those components. But there's so many ways of approaching it, and there's certainly a few very loud voices out there that are advocating for one way or another. Um, and for as someone that's like kind of building product, it's about also figuring about how can we work in all these different environments, and anyone that's kind of building software now needs to kind of keep in mind around how do you best fit in this new world of deployments and a plethora of ways of deploying applications.
Yeah, well, there is a ton of different ways of deploying it, and I think you hit the nail on the head when you said that there are some loud voices out there, and those loud voices may have good information, but they might not have the information that's going to be pertinent to you.
Mhm.
So at the end of the day, the answer to that question, it's the cop out. It
Yeah,
depends, right? It
yeah.
depends on your use case. It depends on your business case. It depends on, what you're expecting, what your users are expecting, what your customers are expecting. Uh, and at the end of the day, I guess the answer could be just as simple as spend the least amount of money to get the most amount of performance. And as you need more performance, spend more money and see where that gets you.
Yes, as the zero interest rate phenomena is over.
Yeah, exactly. So you mentioned deployment models,
Mm.
and I wasn't going to quite go there right now, but since you opened the door, let's walk through it. This was another one of those areas of questions, right? Which is around deploying software. And there's, of course, a larger question here, a larger set of questions here around software development lifecycle, software management lifecycle, right? Of which deployment is an important part,
Yeah.
but it's a part. So when we're talking about monoliths and we're talking about microservices and we're making the distinction that these are opposite ends of a spectrum, although again, the lines are getting real blurry now. What are some deployment models that we should be thinking about in terms of managing, say, one or the other, and then we'll figure out what it looks like in the case of smooshing them together?
Yeah. So when it comes to deployment of services which are outside of the core of what your application can do, there's a few things you kind of need to consider. So, firstly, what do I mean by non-core capabilities? So, authentication, authorization, logging, observability, what your underlying database is, even that could be seen as something that's non-core to your business. It's all about making decisions and trade-offs for what's kind of best for your application for your particular use case. If we look at like databases, you could just go with the standard, Postgres, SQL, etc., RDBMS, or you might go and look at something that's more like a document store. You might go and look at Mongo or FerretDB or these or Couchbase, those kind of things that sit on top of these particular systems. And it's all about kind of making what makes most sense for the actual application you're building. When it comes to things like authentication and authorization, you have kind of options to go and build your own authentication, or you can go and deploy or integrate with a commercial product or an open source project. So now you need to go and run that somewhere. Same with authorization. You can go and build it yourself, or you can go and take something like Cerbos and plug it into your stack. And that's when you'd have to start worrying about deployments. Now, if your application is a monolith, it doesn't mean that everything should be built into that single binary. Being able, unless you want to go and build your own authentication, authorization, logging, data store, everything into your monolith, you're going to want to go and plug in those things. So even with a monolith architecture, you still probably going to have to be starting to deploy companion services or sidecars is the term Kubernetes, where you want to go and deploy these services alongside your monolith, and then the application can just kind of call out for it. And then in the microservice world, these kind of auxiliary components or kind of non application specific components are just another service in your microservices architecture, be it something you're running yourself or some external service that you're calling out to. The biggest thing for me when I think about this is, and what we recommend to users, is focus on what the metric you're trying to optimize here for. And the biggest metric when it comes to authorization or even authentication is actually latency, particularly with authorization, but also with authentication. And then that really should drive your decision around where and how and what the trade-offs are when it comes to deployment. So deployments, you could go for like one centralized service, which all your either each of your instances of your monolith or all your microservices call into. And there's one central service that's simple to deploy. It's just there, it's running, and then everything talks to it. Um, but in the case of running horizontally scaling, you're going to be having to call out across to different nodes in your cluster or different machines in your VPC to go and hit that centralized service. And so you're going to just even inside your VPC or inside of your data center, you're going to add latency versus something that's kind of embedded or on the same box of it. So for the latency sensitive systems like authorization, it's worth going that bit further and say, okay, well, we want to ultimately reduce the number of hops possible to make a permission check. And so you start looking at things like, to use the Kubernetes terms, like daemon sets or sidecars. So what a daemon set is, it basically guarantees there's be one instance of your authorization system running on each node in your cluster. And that way it's always the calls being made on the same box. It's not having to go out to another box on your network. Or a sidecar actually runs it inside of the same pod in the Kubernetes world. But essentially, this is a binary that's essentially running on local host to the rest of your application. So it's a local call over some port to go and interact with it. And for those really key latency sensitive operations like authorization, that is something that we highly recommend to users. But really, it then comes back down to that decision of, do you want the ease of centralized deployment and management, or do you want to optimize for lower latency but a slightly more complex deployment and cost ultimately, because you're running more instances, you're going to have more compute being used. So really think about what is the metric you're optimizing for, manageability or latency. And that really should influence your deployment model rather than what the latest and greatest on Twitter says you should do when it comes to the deployment.
So again, it comes down to, what is your use case,
Mhm.
right? Do you need to have the responses coming fast and furious with extremely low latency? Then that you might be looking at something like a sidecar deployment,
Yeah.
assuming you're using Kubernetes there. That makes sense. What if, heaven forbid, we're not using Kubernetes?
Uh,
I mean, I know it's
uh,
ridiculous to consider in this, the year of our Lord 2024, but what if we're not using Kubernetes?
yeah. Well,
Like,
thankfully
what
we
are
have
some
this.
what are some ways of thinking about deploying in a non-Kubernetes context?
Yeah, I mean, thankfully we're now in this world where pretty much we've convened on a container being the most common way of distributing sort of built assets and built services. People may be familiar with things like Docker Compose. If you're running a stack on your laptop, for example, you might just spin up a Docker Compose stack rather than spinning up a whole Kubernetes cluster. It comes with all sorts of overhead. A lot of these self-hosted is kind of a weird phrase, but like self-managed deployment models that you just get a VPS and put something on it, like Camel and there's a few others out there now. Doku was one back in the day. They just work in containers. And what it ultimately spins up on that machine on the base OS is a Docker Compose stack that's running instances, and maybe put like a reverse proxy in front of it along the way. Um, and containers are a great abstraction for this. There's more I would call them more niche things right now. There's like Nix is another one, which is like a declarative operation stack for operating system stack the whole way. But when it comes to spinning up a service, you got to run a binary somewhere, be it a container or a binary directly, and picking an orchestrator. And I think Kubernetes kind of won that battle. For those of you might remember, like Mesos and those sort of things in the past. That was where I kind of started out on the orchestration side of things. That was a fun journey. Thankfully, we're now in a world where things are a bit more standardized, and there's even ways now that you can kind of get the Kubernetes-esque API without the full Kubernetes stack, which I find quite interesting. But having that kind of abstraction layer on top of the underlying operating system, I don't think anyone particularly wants to go back to running shell scripts on like a cron job or something, or inject shell scripts into a cloud init and those kind of things. But yeah, it's possible. Those are kind of the approaches, and use the abstractions we now have, like containers. In case of Cerbos, we also publish Linux binaries if you want to go down that route, or in Mac binaries. But containers, standardizing our containers as the format, and then picking a runtime or an orchestration that makes most sense for you. And if you're on a single node, Kubernetes may be overkill. Go and have a look at like a Docker Compose stack.
Or go take a look at K3s, for
Yeah,
example, right? If you want to dip your toes into the world of
I,
Kubernetes, K8s, but you're not quite ready to go full 10 toes in when you're standing on business. K3s is a good
Yeah.
potential option, right?
I mean, it's nice side note. I have in my garage here a K3S cluster across three old 1 liter computer type things running all my home automation stuff. And K8S was just overwhelmed the CPU memory on those things. And K3S is much nicer abstraction. Well, simplified, stripped down deployment, I guess. But I still get to things like GitOps and stuff because it is just the Kubernetes API.
It's fully compliant, right? Like
Mhm.
it's absolutely the Kubernetes API. It's just, a single binary,
Yeah.
which, it's a different ballgame entirely, right? All
Yeah.
right. So, oh, and by the way, out there, if you're watching this, and you are still injecting Bash into your cloud inits, no shame, man. If it's working for you, and like you've got no problem with it, and you feel good about what you're doing, keep doing it, right? Like, don't go reinventing the wheel. Don't go changing things unless you need to. If cloud init and Bash scripts are working for you, man, God bless, right? It
Simpler
warms
times.
it warms this old system administrator's heart every time I see code examples in Bash.
I had a conversation with someone the other day who was they were using Cerbos, but the way they were ultimately kind of deploying both their application and their policy files was just straight up FTP onto a node, and it worked. And they didn't have to worry about it. Things like Puppet and Chef are still around, if you remember those. Um, uh, and if it ain't broke, don't fix it. When it comes to maybe re-architecting an application, that might be a good time to relook at it again. But there's lots of great abstractions out there now that kind of remove you one layer from the underlying OS, and so you don't necessarily have to deal with Bash. But if it works for you, don't fix what ain't broken.
Well, that's just it. I'm an old school sysadmin, so a lot of times if I need to like do some data processing or I've got like a CSV or I got to do something, I honestly just go straight to Bash and
Yeah.
I'll pipe it through sed. I'm okay with that, but I certainly don't expect anyone else to subject themselves to the horrors
I,
either, right? So.
I think the most common command line I run in my terminal is history pipe grep, trying to find the command that I did like 3 weeks ago that I can't remember how to do now.
Right. Well, shout out to Atuan, if you're out there, which is just a way of keeping all of your bash history across all of your machines, and it gets backed up. It's all encrypted, and then that way you can actually just grep across every machine that you're on, assuming you're running it. That has saved my hide more than a few times over the years. Um, so this actually brings us. These segues, by the way, are great. I'm not planning any of them, but they're working out really, really nicely, and that brings us sort of to our next broader group of questions that again we've gotten not only recently but just they're evergreen questions, right?
Mm,
And that's around thinking about our careers, thinking about the work that we do and why we're doing it. So yeah, it's good to deploy and it's good to scale and it's good to talk about stateless and so on and so forth, but all of this is generally in the context of gainful employment under a moderately capitalist system. So within the context of thinking about the work that we do and why we do it, you are currently head of product. I think that's your official title
mhm.
um, here at Cerbos. Is that correct? Yeah, I'm mixing that up.
It's a startup life. It's a bit of everything.
Yeah, that's fair, right? Yeah, people ask me what I'm doing over at Cerbos, and I'm like, I open source engineer. I don't know, just whatever. I computer and I talk, and things happen, right? Uh, but so in your role, and we'll call it head of product,
Mhm.
right? Like, what does that actually mean? You said you're an engineer at heart. We're sitting here, we're talking nerdy,
Yeah.
but what are you actually doing at Cerbos? And why are you doing it?
Yeah, I mean, it comes back to fundamentally why we created Cerbos coming up to 4 years ago, beginning of next year, which is authorization and access controls and roles and permissions and that whole space is something that myself, Emery, our CEO, Sheriff, our CTO, we've had to go and build the systems numerous times in previous businesses. We're talking between the three of us about a dozen times from previous lives. My personal experience was the company I was at before this. We built an authorization system well, we started doing it in January. We shipped the first version in March. The business requirements changed, and we had to do that project again. And we did it 3 times in 1 year. We ended up having to rewrite how the authorization system worked three times because the requirements just kept changing. And every single time I've done this, and I've done it both as the guy that had to write the code, and I've also done it as the product guy that had to sort of define the requirements later. I was like, why is there just not an off-the-shelf solution for this? And there are some fantastic open source projects out there. which kind of do this, but they focus on the infrastructure level, or they focus on the network level, or they focus on the cluster level. And what was really we felt was missing is someone that was always built, full stack B2B SaaS type applications was the application level. You have these esoteric requirements from sort of enterprise customers that want to permission their users in certain different ways that are bespoke to them based on their organizational hierarchies. You want to lock down things based on, geographies is a very kind of common one that comes up, particularly at the time when things like the safe harbor agreement between Europe and the US fell through. And every time it's like, why are we building this again and again and again? And why am I wasting 3 months of mine time and the entire engineering team time to build something that really is sort of undifferentiated? It's not core to what our business does. One life it was building a supply chain management system, another life it was building a MarTech solution, in another life it was building a fintech system, in another life it was building a fitness kind of Peloton type system. And I was like, there's nothing really specific to our industry or our vertical when we're building this thing. Yeah, I'm still wasting time, money, resources doing this. And so the timing kind of came right, and we're like, right, well, let's go and solve this once and for all, and roll on us forming Cerbos. Managed to raise some funding and kind of got going because there's recognition that this is something that needs to be solved, and the timing was right for both us and also kind of the industry, we think, to get going. So my role at Cerbos really is about taking that personal pain I've had and also pain from my peers and all the kind of users we've spoken to and turning that into a product that solves it. So hopefully one day you will never have to go and build this yourself unless you happen to be starting an authorization business, I guess. Is just an off-the-shelf product to it. And the great thing there is I've been in the shoes of our users, both from the engineering and the product side of things. So the first year of Cerbos, when we started building this thing out, we were just literally like, right, just going to solve this pain we had ourselves. And then thankfully, the joys of open source, it's out there, and we actually got very early traction. We got people, starting the repo, using it, running it, joining our Slack community, like some of these questions that come from today, asking and pushing the boundaries of sort of what's possible with Cerbos and trying to build on capabilities. And so my role has now shifted from, right, let's just build the pain we had, to really then going and distilling and understanding what these other requirements that I personally never had to deal with before when it comes to authorization, but we're hearing from large businesses that are working with us. Take Utility Warehouse, go and take blockchain.com and these kind of large businesses that are using Cerbos today with all sorts of requirements. And my role is, product is now taking those requirements, figuring out what that can do, what should be an open source project, what can go into the management control plane we have with Cerbos Hub, and doing the more kind of day-to-day product side of things. But I also get to still nerd out with fellow engineers and developers because I've been in those shoes and build some fun demos and hack on some things to really sort of dig into those use cases. And no 2 days are the same in my life right now, but that is a mixture of both startups and also just having a baby.
Well, congratulations on just having the baby. I'd say that is the product that needs to be managed the most. But so you mentioned sort of doing product stuff. Can you dive into that a little bit more? And explain it like I'm five, or at least explain it like I don't know what product means. Like, what does that word mean? What is that role?
So there's a very good definition which one of my previous sort of managers and mentors told me, which is product or product management is filling in the white noise, which I never really got at first. And the analogy is kind of used if you think of like old school TV where you have the static and aim is you want to fill in all the blanks. You want to get it kind of a solid vision, sort of a solid product at the end of the day. And you build a product team, you've got great engineers who can do stuff. You've got a great team of DevRel who can go out and really understand and sort of feel the pain of users. You've got a team of marketing who want to go and push these things. You've got a sales team who are actually speaking to customers, etc. And really the job of product is to fill the gaps between all those people. So 1 minute you've got engineers who need some input on how something will work like an API level. The next you've got to go and work with your UX team to make sure to go through some mocks and come up with some workflows. The next you're doing user interviews to really understand What is your pain? Does this solve it? You got to go and help with some like go to market activity and help. How do we talk about some capability to developers with the open source project, or how do we go and talk to um, commercial users of the commercial product? And I think product manager is one of the least defined jobs in tech as a whole. And I find it really hard to explain it. And the only way really I can explain it is it's a bit of everything, and it's basically filling in the gaps between all the other different defined functions in terms of building a business. A lot of people will just focus in on it's just speaking to users and turning that into a roadmap. I think it's much broader than that, but it's so broad, it's a bit of everything. And so it takes someone that's quite happy with context switching to do this role. And thankfully, I'll say thankfully, maybe not thankfully, I'm the kind of person that gets bored very quickly. And if I was doing any other job, I think I would go mad. And thankfully, in the case of Cerbos, there's a lot of my own previous experience I can lean on, but also we have fantastic users, both of the open source project and our Cerbos Hub product, that are very good with direct feedback. And I think developers are very good at this particularly. So a lot of my time is actually taking their feedback and then figuring out, okay, how can we evolve? How can we update the product and drive these things?
That makes sense. I like your analogy there of filling in those gaps, right? There's an aspect here that, if I'm understanding correctly, is a lot about connecting the dots in a
Hmm.
lot of ways, right? So we've got, Team X and Team Y and Role B and Role 9 over here, and they're all doing their jobs great. And product is sort of the glue. Glue's the wrong word. Almost like the webway, the pathway that connects all these things together, right? We're taking these functions, we're we're mixing them together, we're taking some information from here, we're taking some
Hmm.
functionality from there, right? And building
Yeah.
a thing out of that.
Yeah. And it's very easy to make that sound very kind of big-headed and like I'm the center of the universe and I get to pull all these strings and I'm like Thanos with the Infinity Gauntlet and stuff. The way I look at it is it's about facilitating speed. So that is, you know, unblocking a developer because they can't, ticket isn't well defined, which the product person should have defined properly in the first place. Um, or it's about, getting the right people connected. It's about, doing the desk work on sort of some trend in the industry. It's about really how can I make sure the experts that we've hired for specific jobs inside of the company can do their job and do their job most effectively with the least frustration and the most insight. And if I do my job right, then I almost shouldn't exist because these teams should be autonomous. These teams should be able to kind of do everything they need. And if they're unblocked, then in theory, I can just go and put my feet up. But reality of running a business, that's not the case.
Yeah, I think very few jobs can actually work themselves out of a job. I know it's the holy grail of a lot of roles, but in reality, that
AI solves that, doesn't
oh yeah, for sure, absolutely, yeah.
it?
DevOps too, right? Like the whole point of DevOps is that if you do it right, you won't need it anymore. Yeah, how'd that work out? But yeah, very good. Well, thank you. I appreciate you diving into that. So we're basically at time. So I do want to respect your time, and I respect the time of our viewers as well, of course, of our community. So thank you very much, Alex, for
Thank you for having
taking the
me.
time out of your day to answer these questions. A lot of really good fuel for thought here to mix up some metaphors. A lot of additional sorts of things that we can be talking about, things that we can be spinning off on. So if you have additional questions or additional topics for conversation, don't let it stop here, right? Keep chatting on the community Slack, keep hitting us up on LinkedIn, keep coming over to our booths or coming up to us after talks at conferences. However you want to just get in touch with us to chat with us, we're always happy to be speaking with the
Yeah.
community, either through a medium like this or in person or whatever, right? Alex, what's a good way to get a hold of you if people had some more questions about product or about scalability?
Yeah, absolutely. I'm on Twitter, Alex Olivier, and also probably LinkedIn, the two best channels. And speaking of booths, I will be in Salt Lake City next week at KubeCon. So if you happen to be there, definitely swing by. We have some exclusive swag to give out as well.
We actually have a really good raffle, an
We do.
excellent
Don't give it
raffle.
away. Don't give it away.
I'm not giving it away. I'm not giving it away. I picked out the prize and it's really cool. So
All I hope is that my bags arrive in the US because I have been to a conference where all our swag got lost by the airline. So that was fun.
wow, that sucks. So yeah, so definitely hit up Alex. Definitely check out the KubeCon booth if you're there in Salt Lake City next week. If you are not at KubeCon and instead you are in Lisbon for Web Summit next week, myself and another co-founder, our CEO, Emery, will be there on Wednesday and Thursday. Our booth is on Wednesday. Emery's going to talk as well. So definitely come say hi. We'll be there. We'll have some things to give away and whatnot as well. So thank you again, Alex. Really appreciate
Thank
it.
you.
Thank you again to our lovely community. Appreciate having this opportunity to spend some time with you, to interact with you, to answer some questions. And we will see you again on the interwebs. Until then, stay safe, everyone.